For the following exercises, let S be the hemisphere x squared plus y squared plus z squared equals 4, with z greater than or equal to 0, and evaluate each surface integral in the counterclockwise direction. So let's take a look at number 281 here. When I look at this double integral of the surface area of z ds, what I'm thinking of is the formula for this. So the formula for this is the double integral of f uv times the norm or the magnitude of tu cross tv dA. So the first thing we're going to need here is this RUV. That's where we're going to get tu that from and tv from, and we're going to be able to plug in into our f, which is equal to z here, the u and the v. So we're going to need a transformation here, and we're going to need that parameterization of RUV to do it. So when I look at the x squared plus y squared plus z squared equals 4, I really see x squared plus y squared plus z squared equals 2 squared, which this here is a sphere of radius 2. So right away my mind goes to spherical coordinates. So if you can think of what those equations are, we get the spherical coordinates here. So x equals rho sine phi cos theta, y equals rho sine phi sine theta, and z equals rho cos phi, and then rho squared equals x squared plus y squared plus z squared. And the first thing I see there is this rho squared plus x squared plus y squared plus z squared, and I see this equation here, x squared plus y squared plus z squared equals 4. So that tells me right away that my number squared gives me 4, so that means rho is going to be 2. So there's my first variable. Now again, I have 3 variables here, and that accounts for the 1, and then I have my u and my v. So I can say my u equals phi, and I can say my v equals theta. So there we go. I assigned all my variables. Now all I have to do for my RUV is just plug those in accordingly. So the first component is my x. So instead of rho, I'm going to write 2, and then I have sine phi, but instead of phi, I'm going to write a u. And then I have cos theta, but instead of theta, I'm going to write a v there. So there's my first component of my RUV. Now my second component is going to be 2, because that's my rho, sine of phi, which is sine of u, and sine of theta, which is sine of v. Now for the third one, my rho is 2. Cosine phi would be cosine of u. So there's my RUV there. Now I can find my TU and TV. And I will do that by taking the partial derivative with respect to u first for my r. And to do that, that's going to be 2 cosine u cosine v. And there's the first one. And then the second one is going to be 2 cosine u sine v as the second one. And then for the third one here, with respect to u, it's going to be negative 2 sine u. So there's the first one. Now we need an RV here. And then for the first one, it's going to be negative 2 sine u sine v. And then for the second one then, remember it's with respect to v now, so we're here. That's going to be 2 sine u cos v. And then for the last one, with respect to v, that's going to be a 0. So there we go. So that's our RU and RV there. And now what we're going to do is take the cross product of those. There's my I, there's my J, and there's my K. So our first one, remember, that's going to be the I. So that's going to be my first component here. And that means I'm going to times these here minus timesing those there. So that the first one's going to give me 0, and then minus a negative is positive. So that's going to be 4 sine squared u cos v. And then for the second one here, Oops, I am going to have to move this down. I just looked at that third one there and realized, wow, that's going to be a long one. So I will have to move this down. So there we go. Move it down a little bit more. Comma. And then for the J here, I'm going to have to negate it. So I put that in right away. And then that's going to be 0 times that expression, which is 0, and then minus a negative times negative is positive, which the minus gives me a negative back. And that's going to be 4 sine squared u sine v. And there's my middle term. And then the k here is my third one. That's going to be the third term here. Now I'm going to have to take the product of those two there times those two there. So that's going to give me, so there it is. And what we're going to do is we're going to clean it up from here. Because notice from both of these, we can actually pull a 4 sine u cos u out of both of those. And notice we're going to end up with a cosine squared v and a sine squared v. So I'm just going to write that out for you below. So then there it is. And this piece here is actually going to give me 1. So then that's going to result in, now what we're going to do is we're going to take the magnitude of this. And I'm just going to do this on the next page because we're definitely going to need some more room here. I will keep this part kind of short and sweet, just so you know I'm not going to get into all the detail. But if you want to pause it and look it over, definitely do so. So for the magnitude of this, we're going to see actually a nice result here. And it'll make a lot of sense, I hope. So now this is going to equal the square root of, and now I'm just going to square each of those. So we end up with the magnitude of all of these components squared. And then all we're going to do now is simplify here. So the first thing I'm going to do is I'm going to look at the first two expressions here, and I'm going to pull, let me use a red here. I'm going to pull a 16 sine the fourth out of both of those. 16 sine the fourth of u from both of those. So now the inside of this here is going to be a 1. So we get square root of 16 sine fourth u plus 16 sine squared u cosine u. So now I'm going to pull a 16 sine squared u out of both of these here. And that's going to equal, oops, I should have left those, I will. There we go. And that's going to give us the square root of 16 sine u squared times sine squared u plus cosine squared u. And those are going to give me 1. So I actually end up with the square root of 16 sine squared u square rooted. And when I square root it, I get 4 sine u. And if we remember the Jacobian for spherical, it's actually rho squared sine phi. And remember, our phi was u here, and our rho was 2. So 2 squared gives me 4. So I'll never have to do this again if I'm dealing with spherical here. I just know it's going to be my Jacobian, which makes sense. Why I just have to take that area. Now let's go back to it in a second here. So there it is. And so this is actually my formula I'm going to use here. If you guys can see that, that's my formula. So we're going to take that now and just plug everything in here. Now remember, my z is my FUV. And I got to plug a u in for my a UV in for my z there. And then we'll have that FUV. So let's talk about that now. So then this is going to equal, and I believe my bound's open for the time being. We'll talk about that in a minute. So my FUV, I will need to know what my RUV was. So, and remember here, this was just a z there. So that means I'm going to put a 2 cos u in place of it. That's a sub. And then my TU cross TV, the magnitude of that, that's going to be times 4 sine u. And then we're going to talk about now du dv. Now remember, my u was phi here, and we're talking about a sphere, but not the whole sphere though. It said the hemisphere. And remember, my z is greater than or equal to 0 here as well. So that means it's going to be above the xy plane. So if I think of the picture of this, so then if I think of phi starts at the top at the upper z and it goes all the way down. But notice here, we're only going to the xy plane. So that tells me for my u then, since my u is equal to phi here, I'm going to go from 0 to pi over 2. And my v then was equal to theta. And if we look back, that's where we see these at here. And my v was equal to theta, and my u was equal to phi. So my v then is going to go from 0 to 2 pi. And the reason why is because I'm still going to take this all the way around to fill it all in. And not the whole volume here, but just the whole surface area. And that's what we're dealing with here, this surface area. So then this is going to equal 0 to 2 pi. And then the other integral, 0 to pi over 2. And that's going to be 8 cosine u sine u du dv. So instead of a u sub, I'm going to call it an a sub because I have a u in here. So I'm going to say a equals sine of u. So then dA equals cosine of u du. So I'm going to put it in place of cosine u du dA. And then I'm just going to plug in my a for my sine of u. So we're going to get the integral from 0 to 2 pi, which we haven't touched yet, 0 to pi over 2, which we're getting to, and that's going to be a dA dV. Okay. So then when I integrate the a there, that's going to be 1/2 a squared. So the integral from 0 to 2 pi, and then 1/2 a squared from 0 to pi over 2, and then dv. And remember here, we do have an a here. A is sine of u. So we get the integral from 0 to 2 pi of 1/2 sine of u squared from pi halves to 0. Now I know when I plug in pi halves for u, the sine of u is going to be 1. And when I minus the lower bound, that's going to be sine of 0 is 0, so it's going to be 0 squared, which is 0. So we're actually going to get here the integral from 0 to 2 pi. And this is going to be 1/2 times 1 squared. So I'm going to write that in there, minus 0. So I'm just going to leave that one dv. And then that's really the integral from 0 to 2 pi of 1/2 dv. So now, what this does, I'm going to actually integrate the 1/2 now. So that's going to be 1/2 v from 0 to 2 pi. As I get towards the end, I noticed I missed one component here. So there was an 8 here. And all I really have to do is just carry it along to each step here. And I didn't need it yet anyway, so I can just put that 8 in for each step here. And then I'm going to have for this last step then, and I just kind of noticed it when I looked up. So this is really going to be an 8 times this thing here. So that's okay, not a big deal, it's just a constant. So then I'm going to end up with the 4 here. And then when I take the 8 times 1/2, and then I'm going to plug in the 2 pi minus 0 here. And that's the upper bound minus the lower bound. And that's going to then equal 8 pi. Glad I caught it at least before the very end, even though it was right towards the end there. But yeah, just slide that 8 in all the way through. And then in the last step, we can just times it by 8, and it makes it okay. So there's our actual answer for this 8 pi. And it is a lot of work to get there, but one thing I wanted you to see is I didn't have to do all that work, because if I understand the Jacobian here, it's really just that rho squared sine phi. And my phi is my u for this problem here, and rho was 2, so that's why I got the 4. So from now on, I don't have to go through all of that if I'm in spherical. So, nice answer. A lot of work.